Hi everybody, this is just a follow-up video for some of the harder problems we did with parabolas. I'm going to start by reviewing example 14 in your packet. Something you should note that for the parabolas we do today, we're going to use a similar idea to what we did when we found the center and radius of a circle equation. When we were given an equation of a circle, we always found the center to be the negated values of the x and y parentheses. For example, the -4 became a +4, and the +3 became a -3 when determining what the center of that circle was. Today, what we're going to do is start with writing the equations of parabolas given a picture. So if you look at example 14, I first am going to look at step 1 and identify whether it's an x squared or a y squared parabola. This parabola is x squared. The reason I know that is because it opens upward. X squared parabolas open either upward or downward, whereas y squared parabolas open left or right. Now, in order to write the equation of a parabola, I need to know step 2, the vertex, and step 3, the value of p. If you take a look at this parabola, the vertex is the turning point. The vertex of this parabola is the point 3, -2. The value of p, if you don't remember it, is the directed distance from the vertex to the focus. So I'm going to start at the vertex and count to the focus. I'm going up 1, up 2, up 3. So the value of p is 3. Now I'm going to plug that information into my parabola. The vertex is a point x comma y. So instead of this x squared, I'm going to do the same thing I would do if I was writing the equation of a circle and negate the 3. That's x minus 3 squared. The next thing that comes up is 4p. Well, 4 times 3 is my 4p. And then instead of y, I'm going to do the same thing I would do if it was a circle and negate the -2. So that becomes y plus 2. For a final equation of x minus 3 squared equals 12 times y plus 2. Let's move to example 18. If you look at example 18, now they want you to find the equation for a parabola, and they give you the vertex and the focus, but they don't give you the picture. So let's draw it. My vertex is the point 3, 4. Plot it, put a V. My focus is the point 5, 4. Plot it, put an F. A fact you should know is that the vertex of a parabola always hugs the focus when we draw the parabola through it. So now I know that this would be a y squared equation because y squared parabolas open left or right. Again, the parabola hugs the focus. Now, if my vertex is 3, 4, I need my p-value, and then I'll be able to write the equation. P is the distance from the vertex to the focus. 1, 2. So the value of p is 2. In case you are wondering why p has been positive so far, it's because p is a directed distance, and we have been moving in the positive direction on the x or y axis. If you wanted p to be -2, your parabola would be facing left in this case instead. Now if you fill in the equation, remember the vertex is an x and y value. So instead of y squared, I'm going to negate the 4 and have y minus 4 squared equals 4 times the value of p, which was 2, times x minus 3. That leaves me with y minus 4 squared equals 8 times x minus 3. Moving into the mixed practice section. If you look at example 4, tells you you have a vertex at 6, 2, and a focus at 4, 2. So now, if the parabola hugs the focus, it's facing to the left, which means that it's a y-squared parabola. Additionally, it also means the value of p is negative, because to move from the vertex to the focus, you're going -1, -2. So your answer here would be the only solution that has a y being squared. This is x squared, no good. X squared, no good. X squared, no good. So this is your answer. Now, some people in class were like, well, where's the 8 coming from? If you were to actually write this equation, the vertex is xy, or 6, 2. So if you wrote y minus 2 squared equals 4 times p, which was -2, and then x minus 6, this Regents was a little tricky for this problem. They wanted you to solve for x minus 6. So if I cleaned it up just a little bit, all I have to do here is divide by a -8, and I've got x minus 6 equals -1/8 times y minus 2 squared. You could actually leave it in this form, but the multiple choice is just pulling out the 1 from the numerator and the -8 from the denominator. But again, you didn't need to go that far if you realized it's a y-squared parabola and the only choice with y squared was choice 2. And now the last one that I'm going to do with you guys from the video is number 11 from the mixed practice. This problem is very slick. It's telling you to find the equation of the set of points which are equidistant, and then it gives you a point, which we know is the focus, and a line, which we know is the directrix. It doesn't call this a parabola. Instead, it uses the definition of a parabola. Now, we know that we're going to have to do the parabola because it's in a parabola packet, and that's been the focus for this unit. However, when it comes to the Regents, we need to be able to identify what they're asking because it's going to be a mixture of all the questions you've learned all year. So the set of points equidistant from a point and a line is the definition of the parabola. Let's sketch it. If the focus is 4, -2, and the directrix is y equals 4. That means it's going to cross the y-axis at 4. We need to figure out what the vertex is. Remember that the vertex is halfway between the focus and the directrix. So the vertex would be, if this distance right here is 6 units, the vertex would be 3 up. 1, 2, 3. That vertex would be at the point 4, 1. The vertex has the parabola go through it, and the parabola hugs the focus. So we can tell that this is an x squared parabola. X squared parabolas go up and down. Change this to 4py. Now, here's my x and my y for my vertex. I'm also going to need the value of p. The value of p is down 1, down 2, down 3. So p is -3. We've got x minus 4 squared equals 4 times a -3 times y, or x minus 4 squared equals -12 times y. Ooh, I was wrong here. -1. All right, that's it. Come see me in extra help if you still having difficulty.